This is AQA A-Level Chemistry. It is the Introduction to Organic Chemistry in Year 13. So we're going to look at nomenclature and isomerism. In this first video, we're going to focus on the nomenclature that you have already covered in your Year 12 content. And there's going to be lots of opportunities for you to practice following those rules that you have already started to learn. I'm going to recommend that you try them before you watch the answers. I have tried to break down precisely where the name comes from in every single case, and there are more than 40 examples to name or draw within this video. Just having a look here, these are all functional groups that you are familiar with or will need to be familiar with. Some of them won't show up in this video. They will show up in later videos specific to the topics as you learn about them for the first time. So we're going to start off by naming compounds. Have a go. They're in threes or fours. Here's the first three. So if we take a look at A, the first thing that I'm noticing is I have a carbon chain of 6, which tells me that it's hex. There is no other functional group there. It's not an alkene, it's not an alcohol, so it's hexane, and there is no branching whatsoever. However, if I take a look at the next example, and I look for the longest carbon chain, the longest carbon chain here is pent. You can see the 5 carbons in a row that I've highlighted. But there is a side chain coming off it. There's a CH3 coming off, and that means that it's methyl pentane. But it isn't just methyl pentane, because that methyl could be on the carbon that we've drawn here, or it could be on the middle carbon, or the one on the right of the middle. It couldn't go on the ends because that would extend the carbon chain and it would simply be redrawing hexane. But because we have a particular position, we have to number it. And in this case, it is 2-methylpentane. That's not because we're numbering left to right. It is because we are numbering from the lowest end to give us the lowest possible number. Moving on to part C, and we've got our longest carbon chain here is 4, and I've highlighted that so that you can see it. Now, coming off there are 2 methyl groups, so we need to represent that there are 2. We do that by using the term dimethyl. But once again, we need to say where they are. Well, it doesn't matter if I number from the left-hand side or the right-hand side. There's one on the second carbon and one on the third carbon. So my full name for part C is 2,3-dimethylbutane. Have a go at D and E. Now for D, we're carrying on with a similar theme here. The longest carbon chain is 5, so that means it's pentane. And we have got a methyl coming off it. We can see the CH3 there. And the methyl here is in the 3rd position. So it's 3-methylpentane. On the next one, we have got the longest carbon chain is 4. So my name is based around butane. There are 2 methyl groups coming off it. So 2 methyl groups means dimethyl, and I need to say where those methyls are. Now, don't get mixed up because they're both on 2. You don't only use the number once. We need to specify that each of them are on the second carbon. So the name here is 2,2-dimethylbutane. So let's move on and look at F and G. And for F, the longest carbon chain is 3. It cycles back round on itself though. When we have a cyclic alkane, we use the prefix cyclo. So the first one is cyclopropane. On to part G, and we have got 5 carbons. Now those 5 carbons are in a cyclic ring, so that's cyclopentane, but in this skeletal formula, that stick coming off tells us there is a methyl group coming off there. So the proper name here is methyl cyclopentane. Now you don't need to number the position of the methyl group here, because wherever it is, that is what you would number as 1 on your carbon chain. On to H and I. And you can see we're moving into more complicated functional groups now. The longest carbon chain, though, is where I would always start. That's 3. There are 3 carbons in a chain. But that double bond tells us that this is an alkene. So it's propene. And coming off there, we've still got that side chain, so it's methylpropene. Now again, there are no numbers needed here. The methyl is on the second carbon, but if it were anywhere else, it would be extending the chain to become butene. And because of the nature of methylpropene, because of the structure of it, wherever I put my double bond, it would always be in the 1 position. So methylpropene is the full name. Now on to the next one. I've got 5 carbons in a row. So that tells me that it's based on pent. It is an alkene, so it's pentene. But in this case, we do need to number where the double bond is. And it's in the number 2 position. Now again, remember, you don't just number left to right. You are going to number so that the higher priority functional group has the lowest possible number. In this case, alkenes have a higher priority than alkyl side chains. So I'm numbering from the right-hand side. So it's pent-2-ene. Now, I have got 2 methyls coming off that chain, so it's dimethyl, and they are on the 2nd and the 4th carbon. So that's 2,4, dimethyl pent-2-ene. And as you can see, we're starting to get more complicated. Let's move on to J, K, and L. So in the first one, my longest carbon chain is 3, so that's a propane, and I've got an iodine coming off it. So my prefix for a halogen is halo, for iodine is iodo. And that iodine could be on the first or the second carbon. It would give us 2 different positional isomers. So for this one, it's 1-iodo-propane. For the next one, my longest carbon chain is 4, so my name is based on butane. Coming off there, I've got 2 bromine groups, so that's dibromo, and I need to number where they are. They're on the 2nd and the 3rd carbon, so it's 2,3-dibromobutane. And finally, the longest carbon chain here is 5, so that means the name is based on pent. I have got a double bond in there telling us that it's an alkene, so it's pentene, and again I'm numbering from the right hand side this time, so it's going to be pent-2-ene. Now I also have coming off there 2 side chains. I have a fluorine and I have a methyl. Now it's really important you put these the right way round. It's not about their position on the chain, it's about alphabetical order. So it will be fluoromethyl. But I'm still not done because I also need to explain where the fluoro and where the methyl are. My fluoro is on the number 1 carbon, my methyl is on the number 2, so it's 1-fluoro, 2-methyl, pent-2-ene. 4 more for you to try, M to P. So the first one, longest carbon chain, is 5, so that's pent, and it's an alcohol. So my alcohol ends in ol, pentanol. And you can see that I've numbered pentan-1-ol. It's on the 1st carbon because we're numbering right to left here because that gives us the lowest possible number for pentan-1-ol. Okay, the next one, the longest carbon chain here is 4. It's butan. It's also an alcohol, so it's butanol. And in this case, the alcohol is in the number 1 position once again, so it's butan-1-ol. But this time we have to consider that there is a side chain coming off. There is a methyl. So I've got methyl butan-1-ol. But more than that, because that methyl doesn't have to be on the 2nd carbon, it could also be on the 3rd. It couldn't be on the 4th because that would extend it to a pentane chain. But because the methane has options as to where it can be, we need to number it. So it's 2-methyl-butan-1-ol. So the next one follows a very similar theme. We've got butan as our longest carbon chain. We've got our alcohol in the number 1 position, butan-1-ol, and we've got a methyl group coming off again. But we're seeing that chain isomer to N because my methyl this time is on the 3rd carbon. So 3-methyl-butan-1-ol. So then finally, we look at P on this set of questions, and that means that the longest carbon chain is 3, which is prop. It's an alcohol, and the alcohol is on the 1st carbon, so it's propan one ol, and I have got 2 methyl groups coming off it. That means that it's dimethyl-propan 1-ol. Now, technically, you don't need the 1 in front of the ol there, because the only place it can go is on the end of the carbon chain. And we don't need to number the methyl groups. If you have 2 methyl groups on a propan chain, they have to be on the middle carbon. Anything else would be extending the carbon chain. Okay, let's carry on with Q, R, S and T. I said there were a lot of examples here. And for this one, we're going to the end of year 12, really. There's 1 carbon in the first one, so that's methane. And what we've got here is an aldehyde functional group. This C double bond O on the end of a carbon chain. So the first one is methanol. If we look at R, our longest carbon chain here is actually pent. It's not prop, it's 5. And that highlights a really common error that's made. We've got 2 that begin with P. Remember, pent is 5, like pentagon, the shape. So actually, if I put all of that in, I end up with 3 methyl. I've got a methyl on the 3rd carbon, and then I have pentan because it's 5 long, and my ketone group is on the 2nd carbon, so 3 methyl pentan 2-one. So that error's not corrected on the remainder of Q, R, S and T, but remember, it's 3 methyl pentan 2-one. On the next one, we've got a longest carbon chain of 5 again. So that's pentan. It's a ketone group, so it's pentan-one. And again, we need to number where it is. So we're on pentan 2-one there. And then finally, we have got longest carbon chain is 4. That's butan. Again, this time the double bond O is on the end of the carbon chain. So that's butan-al. I don't need to number that, but everything will be numbered from that end. I've got 2 methyls coming off, and they are both in the same position. So it's dimethyl, and they're both on the 3rd carbon. So it's 3,3-dimethyl butan-al. So we're now going to move on to drawing based on names. So have a go at sketching these out and see how you do. So starting with A, well, it's propane, so that's 3 carbons in a row, and I've got a methyl group coming off the 2nd carbon. All I now need to do is fill in the remaining H's. Now be really, really mindful of what you're asked for in the exam. If it's a display formula or a structural formula or a skeletal formula, I'm not going to specify on these. So you can see that I've got a combination here of structural and display. It's certainly not a display formula because I'm not showing every single bond. But that's 2-methyl propane done. So let's have a look at B, 2,3-dimethyl pentane. Well, I'm going to start off with the carbon chain again. I've got 5 in a row, and I'm going to put my 2 methyls on the 2nd and the 3rd carbons. All I've then got to do is fill in the remaining H's, and I've got my final structure. And finally, part C on these ones, 3-ethyl 2,4-dimethyl hexane. So I start with my hexane chain. That's my longest chain, the spine that everything is built from. I'm now adding my 2 methyls in the 2nd and the 4th position. And I then add my ethyl, a CH2CH3 group on the 3rd carbon. Technically, I don't need to number that one. In fact, on this one you do, but often you don't need to number the ethyl group. Now from there, I fill in the remainder of the H's. So let's move on, D, E and F. So for D, it's cyclobutane. Well, let's start with the chain of 4. That's butane. The fact it's cyclo means it comes round into a ring structure, and I just need to fill in the H's now. There's enough space for 2 H's on each carbon. Similar idea with cyclopentane. I've got my 5 carbons in a chain, but I complete that chain as a cycle, which we can see here to make it cyclopentane. And drawing this as a display formula this time, I've got each carbon having 2 H's coming from it. You'll notice that has the formula C5H10. That makes it a functional group isomer of pentene. And then finally, 1,3-dimethyl cyclohexane. Well, my cyclohexane I've drawn out in 1 this time. It's 6 in a cyclic ring. And I'm going to put my methyl groups on the 1st and the 3rd carbons. Doesn't matter where I choose number 1, but I then have to make sure my 3rd is 2 away. So I've got my methyl groups on, and I simply have to fill in the remainder of the H's. So let's move on to G, H, I, and J. In this case, my longest carbon chain is bute, but this time I have got an alkene, and my double bond starts on the second carbon. I've numbered from left to right here. So I put my double bond in, and then I need to complete the H's. Be really careful with this. Remember that a carbon forms 4 bonds. Carbon 2 and 3 already have 3 bonds around them, so I can only put 1 H there. If I move on to H now, 2-methyl-bute-2-ene. Well, my bute-2-ene I've drawn out exactly as I just did, but I've got a methyl coming off the second carbon. You'll notice that I have numbered it from the right-hand side this time. It's perfectly valid to do that, and you might see it presented that way within an exam. On this one, I've numbered with my carbon number 1 on the right-hand side, which means that my double bond starts on the second carbon and my methyl comes off the second carbon. I then fill in the remaining H's, being careful to do that without adding too many or too few. If I move on to I, I've got 2,3-dimethyl-bute-2-ene. So let's start with my bute-2-ene once again. My 2 methyl groups, 1 on the second, 1 on the third, and fill in the remainder of the H's. And finally, on this run of questions, I've got 3-ethyl 2-methyl-pent-1-ene. So I'm going to start with the pent-1-ene. I'm drawing from left to right here. My double bond starts at the first carbon. Everything else has to be numbered from the same end. So I put my ethyl group on the third carbon, and I put my methyl group on the second carbon. And once again, I need to fill in the remaining H's. And I have those here. We're going to move on to K, L, M, and N. So we're on to haloalkanes here. For K, we've got methane, which is a single carbon, and I've got tetrachloro, 4 chloro. So I'm going to put those around the outside. There's no space for any H's on that one. If I go to L, I've got 1,1-dichloroethane. So eth is 2 carbons. I've got 2 chloros coming off 1 carbon, the first carbon. So I've put those here. And that then allows me to fill in the remainder of the H's that you can see here. If I move on to M, I've got 1,2-dibromo, 2-methyl-butane. So I start with my butane. I've put those in. I have got a methyl group coming off the second carbon. So I've done that here. And my 2 bromos come off the first and second carbon respectively. I've got my 1,2-dibromo, 2-methyl-butane. Again, notice bromo before methyl because we put prefixes in alphabetical order. Then I fill in, as always, the remaining H's and I have my structure. And N, I have 1,2-dibromocyclohexane. So let's start with our cyclohexane ring, and I need to add my 2 bromines. Now they're going to be on the first and second carbon. You can start with any carbon being number 1, but you have to then stick to that numbering. So I've gone for these 2 here. And all I've got to do then is fill in, once again, the remaining H's. Moving on to O, P, Q, and R. So for ethanol, I have 2 carbons in a chain and I have an alcohol group, an OH coming off it. That then means that I can fill in my remaining H's. Ethanol, CH3, CH2, OH. If I then look at 2-methyl-propan-2-ol, my longest carbon chain is 3. I have got my alcohol coming off the second carbon, and I've also got a methyl group coming off that second carbon. So that then allows me to put the 3 remaining H's on each of the 2 carbons that have spaces, and I've got 2-methyl-propan-2-ol. Moving on to butan-2-ol, well, butan, that's 4 carbon chain, and my alcohol is on the second carbon, and all I've then got to do is fill in the remaining H's. And but-2-N-1-ol, slightly more complicated here. I've got my bute, but I'm being told it's an alkene, and my double bond starts on the second carbon. So I've done that. I could have numbered from either end to have the double bond in that position. But I've also got an alcohol group on the first carbon, which I've now added, and I can now carefully add the remainder of the hydrogens. Again, remembering the 2 carbons as part of the double bond already had 3 bonds formed, so there's only space for 1 more hydrogen. And then S, T, U and V, and this takes us to the end of the video. Ethanal. Well, ethan is 2. My aldehyde group is a C double bond O on the end of a carbon chain, and then I fill in my remaining H's. If I move on to butanone, well, butan tells us 4 carbons in a row. I've got a ketone group, which is a C double bond O in the middle of a carbon chain. Don't need to number it on butanone, because wherever I put it, it would be in the second position. And then I simply fill in the remaining H's, which you can see here. 2-methyl-propanal. So prop gives us 3 carbons in a row. I've got my C double bond O on the end of the carbon chain, because that's what we determine an aldehyde to be. And I have a methyl group coming off the second carbon. So there is my 2-methyl-propanal once I've added the remaining H's. And then on to V. I've got 3-methyl-pentan-2-one, pent, 5 carbons in a row. I've got my double bond O, my ketone group on the second carbon, which this time I've numbered from right to left, and continuing that numbering allows me to put my methyl group on the third carbon, and to finish off, I do my remaining H's, and we have completed all of the examples. Lots of things to think about there, lots of pitfalls to fall into. Practice makes perfect. Learning the rules is job 1. Applying them effectively is really what's key to success in this area. That takes us to the end of the video. Thank you for listening, and goodbye.